When the sirens wail during an emergency, the universal instinct is to run to the internal safe room. For decades, sealing the heavy steel door of a fortified room in the center of your apartment has felt like reaching the safest place on Earth. But look at this photograph of a recent high-rise strike in Ukraine. When a modern, heavy warhead hits a residential tower, those internal, static rooms are entirely exposed to the outside air, their walls sheared clean off. The initial blast is only the first phase of the danger. A direct hit routinely triggers massive, uncontrollable fires that sweep through the surrounding floors. If you are sealed inside a static box deep within a burning building, that sanctuary becomes a trap. The structure we rely on for civilian defense has a critical architectural flaw when placed inside the context of a modern urban disaster. The standard safe room in Israel is known as a mamad. A mamad is an internal, reinforced concrete room required by law in all new residential buildings. When these were conceptualized in the early 1990s, they were built to withstand lighter rockets and engineered for a skyline made up of buildings mostly 4 to 9 stories tall. Today, our cities look like this. We live in dense, vertical clusters of glass and steel, routinely reaching 30 stories high. The weapons aimed at those cities have scaled up dramatically alongside the architecture. We are now seeing heavy ballistic missiles carrying payloads of 500 kilograms, along with swarms of combat drones specifically designed to ignite enormous fires upon impact. The core vulnerability lies in the geometry itself. An internal safe room is physically tied to the host building. If the surrounding floors or supporting columns fail, the safe room fails right along with them. Moving past the 1990s standard is an absolute requirement to keep civilians alive in high-density warfare. Engineer Baruch Yarmolinsky has developed a targeted solution to this crisis. He calls it the vertical lifeboat, which functions as a heavily protected exterior stairwell. The central concept is decoupling. Instead of burying the safe room inside, you construct a separate tower next to the main building. It rests on an independent foundation, with external walls cast 60 centimeters thick to absorb massive kinetic impacts. By completely removing any structural dependency on the main high-rise, engineers isolate the civilians from the destruction of the main building. Let's run this through 3 stress tests. First, a high-rise fire. Smoke is rapidly filling the floors. Because residents access the external tower via small connecting bridges, the stairwell remains completely clear of smoke, creating a pristine, rapid evacuation route downward. A standard internal room forces you to wait for rescue while smoke engulfs the structure. Second scenario, a direct missile strike. When sirens sound, this tower transitions into a fortified bunker. Heavy blast doors seal shut, and advanced air filtration systems engage. These internal systems generate overpressure. Overpressure is an engineering state where the air pressure inside a sealed space is maintained slightly higher than the atmospheric pressure outside. This physical force actively pushes toxic smoke and chemical contaminants away from the people inside. The final test is a catastrophic structural collapse. Imagine a massive earthquake or a direct hit from a heavy warhead that completely destroys the main building. Because the load-bearing design is completely independent, the host building can collapse into rubble, and the lifeboat will remain standing entirely on its own. This single, decoupled concrete tower neutralizes the threats of fire, missile impacts, and building collapse all at once. This technology has undergone more than a decade of research and development, and it holds official, in-principle approvals from the Israeli Home Front Command. You might assume a standalone, heavily fortified tower would be cost-prohibitive, but constructing this exterior stairwell costs roughly the same per square meter as outfitting a building with standard internal safe rooms. Look at this rendering of an educational facility. The external stairwell integrates seamlessly into the school's facade, serving a daily functional purpose without looking like a military bunker. The actual bottleneck preventing these from being built today is standard bureaucratic friction, delaying widespread adoption. To move this from the lab to the real world, the final step is executing a dedicated pilot program in coordination with the Housing Ministry to prove the system's viability in an active construction project. As our cities reach higher and the munitions they face grow heavier, civil defense is evolving. It is moving away from the static internal box and toward a structure that stands on its own, providing a clear way out even when the rest of the building falls.